Okay, 9-5. Compositions. That just means you're going to do more than one transformation at a time. Do one and then do another one. So you're going to get, instead of getting a single prime, you're going to end up with a double prime. That's all. And you need to do them in the order that it's given. It's not going to say do this first, do the second. Whatever's first, you do first, and then the second one, you do second. Okay? And then there's some theorems that we need to talk about. So let's take a look at, we'll talk about glide reflection in a minute. Let's take a look at an example here, and then we'll discuss glide reflection. So I'm going to graph this information on here. And then we're going to take a look at it. Okay? So, we got 2-1 is A. B is at 5-3. 4-5-3. And C is at 6-2. Okay, so there is triangle A, B.
Jacob.
A, B, C. Now, find the image after the glide reflection. So again, we're going to do the translation first and then the reflection. What's the translation do? Slides it. Which direction are we going to do this one? Left 8. We're not going up or down because there's nothing done to the Y. So 1, 2, 3, 4, 5, 6, 7, 8. That's A prime. C is at 1, 2, 3, 4, 5, 6, 7, 8. That's C prime. And B, 1, 2, 3, 4, 5, 6, 7, 8. B prime. Alright, everybody with me so far? Pretty simple. That's the first translation. Then the next transformation is a reflection in the x-axis. How do I do that? Somebody want to come up and do that real quick? No? It's an easy one. Come on. Show everybody how to do the reflection in the x-axis.
Do you put 2?
2? Yeah, double prime. This is the second transformation. So, she just counted, there's the distance of 1 there, so 1 goes for A prime. C double prime, there's 2 units there, so we go 2 units down. B prime is 1, 2, 3 units away, so B double prime will be 1, 2, 3 units away. Okay, good job. So there is the composition, 2 different transformations. That's what we ended up with. So, begin by graphing ABC, then the graph A prime, B prime, C prime after the translation. 8 units. Left is what we did. Find the graph A double prime, B double prime, C double prime after reflection in the x-axis. Any questions about that composition of transformations? Very simple. Now we have rotations and stuff that we can talk about, which we'll get to. So let's talk about some other things here. Next one. Composition theorem 9.4. Composition of 2 or more isometries is an isometry. Okay. And then example 2. Let's go ahead and do this one. Okay. C is at -2, 6. 1, 2, 3, 4, 5, 6. And D is at -1, 3. So, we are going to reflect in the y-axis. Anybody want to do that? Easy one? Reflect in the y-axis? Nobody? Before I ask you to do something difficult, anybody want to do the easy one? Come on. Reflection in the y-axis. Excellent. Good job. Now anybody want to do the 90-degree rotation? And again, it's counterclockwise unless said otherwise. 90-degree rotation, counterclockwise. Anybody? Shall I pick? Or who wants to do it? Who wants to tell me how to do it? You can do that. What? Oh, okay. So we're going to rotate the prime image, not the original, the prime image. So that's just going to come down here. So D is at -3, +1. D double prime. and C is at negative 6, positive 2. C double prime. Okay, so graph CD we did, reflect CD in the y-axis, has the endpoints 1, 3. Oh, I'm sorry, that would be 2, 6. And D prime is at 1, 3. And then we rotate it 90 degrees. So C double prime is at negative 6, positive 2, and D double prime is at negative 3, positive 1. Okay, so they did switch like Lauren was saying. Any questions so far? Pretty easy? Yay. Everybody's so happy. Okay. Let's complicate it a little bit. Let's talk about this theorem, 9.5. Pretty simple how to do this. Reflections and parallel lines theorem. If lines K and M, so K and M, if they're parallel, then a reflection in line K followed by another reflection in line M, that's the same as a, what do you think? What happened from here to here? If you just went from here to here, what would you call that? Crazy.
Translation.
Translation, that's right. Translation. Good job. If P double prime is the image of P double prime, P, then P to P double prime is perpendicular to K and M. That's important. You understand it's perpendicular. And P to P double prime is twice D. D is the distance between the two parallel lines. So this is a formula. If I want to know the distance from Q to Q double prime, all I have to do is take twice the distance from K to M. That's it. Now watch. This is why. I reflected this over here, so these two are the same, right? And I reflected this to here. These two are the same. So this plus this is equal to that. That's why it's twice the distance. Okay, let's look at example 3. We're just going to do the example. I'm not going to fill in those lines. I'm just going to talk about it. In the diagram, a reflection in line K maps GF to G prime F prime, and then a reflection in the line M maps GF prime to G double prime F prime. FA is 6. DF double prime is 3. So here's D to F double prime is 3. So again, just by what I just told you, this is 6 and this is 3. This distance between the two parallel lines is 9. If you add all those up, you get 18, which is twice that distance. Okay? Obviously, we can put some algebra problems together to do this, try to see some of that. Any questions on reflections through two different lines, parallel lines? Okay. Moving on. Let's try to get to stuff. That's a good one. 9-6, reflections in intersecting lines theorem. Here's one that something you've never thought of before. So these two lines, line K and line M, they make a certain degree. They call it X in your book. Okay, it's X degrees. So if I reflect AB over this line and then reflect it over this line, they're saying that from AB to A double prime, B double prime is therefore a rotation of twice that angle. So if I rotate this to here 2 times this degree, so then in this case it would be 2x, I'll get that same image. So if you have 2 lines that cross and I reflect over both of them, all you have to do is double that degree between the 2 lines, and that's how much you're rotating it. Understand? Well, let's find out. Number 4 here. This is it. In the diagram below, the pre-image is reflected in line K, then in line M. So from here, it reflected to there, from here to there. The degree between the two lines is 68 degrees. How much would I have had to rotate this image to get to that image? What do you do? What do you do? Multiply by 2. How much is it? 136 degrees. A rotation, you need to know that you're rotating it. So a rotation 136 degrees. Instead of doing 2 reflections, you can just rotate it 136 degrees. That's it. Okay. There you be.